I'm going to talk about rectangles in this one, and we need to first figure out what a rectangle actually is. It's quadrilateral because it has 4 sides and it has 4 right angles. There's your basic definition for a rectangle. Now what we're going to look at is one of the properties of a rectangle, and I'm going to go to Sketchpad and take a look at that. And the property that we're going to look at is how the diagonals are related. So what I've done is I've measured the length of each diagonal, and right now it appears that those two lengths are going to be equal, or the diagonals are going to be congruent. Now as I move it, what you're noticing is the diagonals stay congruent to each other. And that will always happen in a rectangle. So diagonals always are congruent in a rectangle. Coming back here, that's going to lead me to this first one. So if the green is true, then the red is true. The green is it's a rectangle, the red things are the diagonals. So on my next slide it tells me that yes, the diagonals will be congruent. I put that right here in terms of the picture, segment AC being one diagonal, segment BD being the other one. Now I want to look at the converse of it. So our original one was if a parallelogram is a rectangle, then the diagonals are congruent. Well, converse will then say that if the diagonals of a parallelogram are congruent, then it is a rectangle. Question is it true? Well, I'm going to come here and I'm going to try to prove it. So what I have is I know it's a parallelogram, that's part of the hypothesis, and I know my diagonals are congruent. So right now what I'm going to do is I have to somehow try to prove that the 4 angles in this parallelogram are right. Now I know that what I'm going to call the green and the blue are congruent. That I know. It's kind of hard to mark on here, and they cut each other, but I do know that they are congruent. I'm also going to come here and I'm going to look at this side. I know that's the side of a parallelogram, and here's the opposite side. And based off my properties of parallelograms, I know that I'm going to call it the bottom side and the top side are going to have to be congruent. I also know that this piece right here is in both triangles. I have kind of the green triangle on top and a blue triangle on the bottom. That's in both of them. Now when I look at that, I see the single ticks, I see the double ticks, and remember that my original diagonals are congruent. So I have side, side, side telling me that the green triangle and the blue triangle are congruent, which is then going to tell me that the corresponding angles are congruent, which would be this one from the green triangle and this one from the blue triangle. So now I'm going to take a couple things. I know the orange angles are congruent. I also know that because it's a parallelogram, these orange angles have to be supplementary because they're the consecutive angles. Well, if they're congruent and they're supplementary, they're not just congruent angles, they are congruent right angles. So I'm going to get rid of those then. Instead of having it marked as just congruent, I'm going to remark them as being right congruent angles. And then I could go through, I'd have to technically do it again for, well actually I don't, because now I have a theorem that says if one angle in a parallelogram is right, then they are all right. Now I look at it, what started off with as a parallelogram with congruent diagonals, I now have 4 right angles in it, so it's a rectangle. And then is the converse true? Yes, it is. So it goes both ways. Now the thing you have to be very careful on this one is this piece right here. If it's not a parallelogram and the diagonals are congruent, it's not necessarily a rectangle. But if it's a parallelogram and the diagonals are congruent, yes, it will be a rectangle. And that's going to conclude the lesson portion of my video on rectangles.